That's a good question. This could take 12 minutes. It could take 25. Could take 35. I don't know. No. I'm sorry. Let me pause this real quick because I didn't know you were going to start asking me random questions. Great. Weirder than normal, that is. So quick, today's 220, 22023. And you'll be starting solving harder square root equations today. Remember that what I said before was that there are multiple, like 4 levels of difficulty. You guys are we're gonna hit level 2, and then that's our limit for this class. Okay, I'm not gonna make you do the other stuff. So just before we get to the harder ones, I just want to give you a quick recap of the easy level ones, like you had these on Delta Math last week, and they were like super cake easy. So an example of a super easy one, again, this is not what you're learning today, would have been like the square root of 3x minus 4 equals 8. So anyone remember? No, that's actually the worst thing you could have said. That's even worse. Right. Yeah, so we don't want to square root both sides because they're already square rooted. I want to do what Eli said. You guys couldn't hear him because you were all yelling like a bunch of primates. I probably shouldn't say that on the recording. We're going to square both sides. Square both sides, not square root. You're going to square the left side and you're going to square the right side. And you're going to get 3x minus 4 equals 8 squared, which is 64. Is that ringing any bells? Nice. Yeah, now you solve it. Now the 4 and the 3 are free to move about the cabin. So you're going to add 4 and get 3x equals 64 plus 4, divide by 3, and 68 can't divide by 3, so you would just leave your answer as 68 thirds. Unless you're a decimal person, then it could be like whatever that is. Good. All right. Yeah, so everyone kind of up to speed on that. You remember that now, how we just square both sides? You have to do that to get rid of the root because the things inside are what we want to be able to move around, but you can't move them around when they're bound up inside the root. So there's a substantial jump. So if you have like a cell phone or something, as I've said it before, I just need you to put them away, like make sure they're gone. Okay. Substantial jump in difficulty today, not because of the what we do, but because of the what happens after we do it. So I've only got 4 examples scripted for this, but I could certainly conjure up more if you feel like we need them. So it's not going to look much more difficult, but you'll see why we did what we did Thursday. You'll remember that Thursday we did a little detour assignment. I hope you were here for that, and I hope that if you weren't, you of course got it off Canvas and did it. It was assignment, I think it was like 10. I think we called it assignment 10. Do you remember that? Where we were practicing our square, multiply, double. Is that 30 questions? Square, multiply, double. Thanks, Mr. Barth. So yeah, I think it was a lot of practice, and it was over and over again that idea of how do I square a binomial. And so the reason that assignment existed is for this moment right here. And so I hope it becomes apparent why we practiced. So when I say, what do we do? Your answer is still the same. Your answer is still square both sides. So that's what we're going to do. So on the left-hand side, I'm going to square away the root like that. And on the right side, watch out. Thursday's assignment existed for this. So the left side, you don't need a math degree for the yellow side. If I square the yellow side, what do I get? Yeah, you don't even have to do any math. Like I said, I use the analogy of a crane. The crane just swoops in and whoop, grabs the root sign and dumps it over there on the side, right? That's not really mathy. The right side is mathy. Anyone want to take a shot now at this is what we practiced on Thursday at what the right side will be, Chance?
Isn't it x squared plus 1 plus 2x plus 1?
was a good try. So that was really actually quite a good try. Here's what if you said this, hope you're listening. This is the unforgivable. Don't write this down. This is the get you thrown out of class answer, right? This is why we practiced on Thursdays, because we don't want to say something so egregious. We don't want to offend the math gods with that. It's square, square, multiply, double. So let us practice again, because every problem is going to start with a square, square, multiply, double. So we got red guy. Square him, what do you get? Then we got blue guy. Square him, what do you get? And so remember that at the end, we put +1, but very much on purpose, we put a space right here because that's the multiply double step. And what is red guy times blue guy? 1x. Double that. 2x. So we're going to slap a 2x in the middle. And so Chance, when you were kind of stumbling over yourself there, you said a lot of really good things. You nailed the 2x. You just had like an extra 1 in there or something, I think. But good effort on that. Are we okay so far? Okay. Square, square, multiply, double. It's literally what we did on Thursday. No, that's as quick as we can go. Now I want you to notice that this is not just an equation that a 7th grader could solve. You found, I'm sure, on the other assignment, the one from Delta before, that the equations that popped out after we squared both sides were insulting to your intelligence. They were like, add 3 to both sides and divide by 4. It was like, wake me up when this is over, easy. These are not. This is a quadratic equation, and you've already taken a whole unit on this in this class, so you should be pretty good to go. So here it goes. Refresher. You know it's a quadratic equation because it's got x squared. And so this is not a typical situation. This is move everything to one side, set it equal to 0, factor, solve. You never thought factoring would come back to haunt you again. So what I'm going to do is I'm going to move this x to the other side, bless you, by subtracting x from both sides. And I'm also going to move this 13 by subtracting 13 from both sides. I won't always show my work like I'm doing right now. I'll generally just move things across, remembering to change their signs as I go. Still with me? Now, here's what's about to happen. The x's are going to cancel, the 13s are going to cancel, and we're going to be left with 0 equals. And hopefully when this happens here in a moment, you're going to look at it and go, I remember these. I'm going to copy down my x squared because he didn't get changed by anybody. What is 2x minus an x? So just plus x. And what is 1 minus 13? So we arrive at this. We'll just let that sit there and simmer for just a moment. Do you guys remember factoring? You remember that in order to solve a quadratic equation like this, what we want to do is we basically want to break it down into those 2 sets of parentheses. Those are called factors, and then find the answers from there. So I need your help. It's been a while. Remember how I had to keep writing an equals 0 for you guys because you're stubborn? So let's get that equals 0 in there right now. And now let's build our parentheses, our shells. What do I know is going to go where these white arrows are? I know I need an x and an x. What do you think my signs are going to be? Plus, plus, minus, minus, or one of each? Why are you so sure of that?
Because you have a negative on the right.
That's all that matters. Thank you. Enough said. If the negative is at the end, then you know there's one of each. I don't even care what's in the middle. I'm not even looking. If the back number is a negative, then I know I need a plus and I need a minus. And now I just got to know my times tables. What numbers multiply to make 12 that I'm interested in?
6 and 2.
For sure, 4 and 3 in this case. And 6 and 2 make 12, and 12 and 1 make 12. But you guys have done enough factoring problems to know that we want to use the 4 and the 3 because of what's going to happen. So this again, right. So what happens is, let's talk about the rinky-dink garbage stuff that you don't get points for. Like x times x is x squared. Yay, we did it. And then, of course, 4 times -3 is -12. Like, yay, we did it. You don't get gold stars for that. You get the gold stars for this blue and this green. What do the blues make when you multiply?
4.
What do the greens make? And 4x and -3x make which is exactly what we wanted. So our factoring is awesome. Now, remember that we have to make the factors themselves equal 0. Is it all coming back to you a little bit at least? What makes x plus 4 equal 0?
Another X plus 4.
X equals negative 4. What makes this equal 0?
Positive 3.
So far, I want to be clear about something. These are not answers. They are what we call candidates. Like, you're not officially president if you're just running for president, right? You're a candidate. And what this means is they basically have to prove themselves. They have to prove that they don't make anything bad. Scale of 1 to 10, 1 utterly lost, 10 easiest thing I've ever done. Right now to this point, where are we? 5.5, 8.5? Did you say 9.5? Nice. We're going to do something with these answers, and you are required to do one of these two things. You're either going to put a box around an answer or you're going to cross it out. Don't do it yet because we don't know if they work. So here's what this means. I'm going to put a blue kind of a little check mark next to this one, and let me show you what this looks like. Go all the way back to the beginning of the problem, and I want to know if negative 4 works. So here's the original problem. Oops, I got a little bit ahead of myself there. Apologies. So that's the original problem copied over there for your convenience, so there's not all that clutter in the way. I want to take my answer candidate, and I want to put it where these little blue arrows are pointing, where the x's are, right? So if you change the first x, the one on the left, into negative 4, you can do a little bit of this math in your head. What is negative 4 plus 13? 9. Yeah, you cannot mess up negative 4 plus 13. It is and always has been positive 9. So the left side says the square root of positive 9, which we all know as 3, correct? Okay. Now, if you take negative 4 and put it where the blue and white arrows are pointing, what is negative 4 plus 1? Does 3 equal negative 3? Are they the same number?
No.
Of course not. One is a positive on the number line, one is a negative. Those aren't the same number. They're as similar as like a cat and an alligator. They're not the same number at all. Here's what this means. It means that the answer, negative 4, is no bueno. Cross it out. Don't scribble it out. I want to be able to see what it was, but you have to cross it. That's your commitment to the world to say, I have checked this answer and it doesn't work. The more maths, if you were to take a bunch more maths, you start to see these more often. They're called extraneous solutions. They're answers that, like, you get them, but they're not really supposed to be there. They're bunk. Now let's head over and let's try this one with the little green check mark next to it. 3. Same drill. Go back to the beginning of the problem. Up here at the top. We're checking positive 3 now, right? So where the blue arrow is, if you put 3, what's 3 plus 13? What's the square root of 16? So the left side says 4, and now he's just waiting for his homie over on the other side. It says, if you equal me, we work. If you don't, we don't work. So if you put 3 in for the other x, what's 3 plus 1? Does 4 equal 4? They are the same number. So x equals 3 does not get across, it gets a box. You are required to do one of those two things with your answers. Box it if it works, cross it if it doesn't. Don't leave it out just floating there waiting for me to decide. The commitment is the box or the X. Yes, Chance. What an intelligent question. I never anticipate that question, and I don't know why I don't, because I would have asked it too. Sometimes one of them will work, sometimes neither of them will work, and sometimes both of them will work. So you just have to check them both and see what you get. Perfect question for that moment. Yeah. You mean, did you understand everything down to the yellow line? Okay, so I just said, what makes x plus 4 equal 0? Well, negative 4 plus 4 equals 0, right? And that's why x is negative 4. And then what makes x minus 3 equal 0? Well, 3. It's the one where you guys learned it is just do the opposite. So like if you see x plus 5, do negative 5.
And then how we got there.
We didn't get x equals -3. Do you mean x minus 3, this? Are you talking about when we were checking them?
Yeah.
Because when we put, remember one of our candidates, I believe, was x equals -4. Does that sound correct? If you put -4 right at the end of that white arrow, what is -4 plus 1? And that's where we got -3. Basically, what it's going to come down to is whenever you get your candidates, you're going to plug them in one at a time, and they're either going to work or they're going to not work. Let's do another problem.
What if you have like, in the problem you have negative x plus 13, and like you have a negative for one of your candidates?
Then it would become a positive. Yeah, a negative of a negative is a positive, right? All right, let's try another example. If you're feeling right now a little like that was no fun, let's try again. I think you'll feel better. Okay, here we go again. So we're going to, on the one side, have x minus 8. And on the other side, we're going to have the square root of 16 minus 2x. What do we do first? Yeah, take the root off. Square both sides. Get used to saying those 3 words. Square both sides. So the red side is the hard side. The yellow side is the don't insult my intelligence side. So let's do the yellow side first. What do we get on the right? Right, as always, there's really nothing to do. It's just lift off the root. The left side is the heavy lifting. And I dedicated a whole day because I didn't want to stop on every problem to explain how this works. So here it goes. There's red guy and blue guy. And if you follow these steps, you just can't miss this ever. What is red guy squared? So I'm going to write x squared. What is blue guy squared? So I'm going to put plus 64. But again, I'm going to very purposely leave a space in the middle. What is red guy times blue guy? Negative 8x, double that. And there's the left side. You'd be surprised. I know that you're a bit sarcastic when we go through this, but you'd be surprised how often people's inability to do that is the downfall. So I know you're over it, but there's still a lot of people that aren't. So everybody good? I agree. So we're going to focus on the left side this time because we want to go wherever x squared is positive. So the x squared is going to stay on the left. What else are we going to do? Nope.
What would be minus 14x?
Minus 4. At this point, basically 16 and negative 2x both say we're coming over, and they're coming to the left because everyone wants to go to the side where x squared is at. Make sense? So I did, without showing my work, I added 2x to both sides, which is why I got negative 14x. And then again, without showing work, I'm going to subtract 16 from both sides, giving me what?
48.
It is definitely 48. Good math. 64 minus 16 is 48. Every single problem you do is going to come to this crossroads. I liked this problem set because it's so repetitive. Like there's going to be variation, like curveballs coming at you. Every single one you get to hear. And now it's time for my second favorite F word, which is
Factor 3.
factor. Oh, you know what it is, bro. Tell me about my signs. Plus, plus, minus, minus, one of each. Definitely minus, minus. Mikhail was on that because they have to be the same if they multiply to make a positive 48. But if they're the same and you got a minus in the middle, they got to both be minuses. Good job. You were all over that like white on rice. You look at the number in the back. If it's positive, then it can only be plus, plus, or minus, minus. Because in math, that's the only way to multiply to make a positive. And if you know that you either have choice 1 or choice 2, you'd have to be a crackhead to choose choice 1, because if you put a plus and a plus, how are you ever going to get that minus on the 14? Am I right? So of course it's minus, minus, right? The numbers, they work as teams. The number in the back, the 48, gives us part of the information, and then his buddy, the minus in the middle, says, let me complete his information. He told you you're the same. I'll tell you then what you both are. So times tables, here we go. What are we thinking of for 48? Definitely 6 and 8. And again, there's a boatload of ways to make 48. There's a lot of factors of 48, but the only ones that are of any use to me are 6 and 8, right? So we've arrived at now the place where we reveal our candidates. And what are our candidates? Correct. So one of them is named x equals 6, and one of them is named x equals 8. And now they're just kind of waiting out there in the storm. Like, are you going to commit to me and box me? Or are you going to throw me away and cross me out? And we don't know yet. We have to plug them back in to see if they make bunk equations or good equations. This last part ought to be pretty peaceful for you. I hope. So let's go back up to the beginning of the problem where we had our original problem. And it said, and again, I'll write it over again so that it's not vandalized. We have input minus 8 equals the square root of 16 minus 2 times the input. So we're going to change the inputs into the candidates one at a time. Let's start with 6. So if I put 6 where these blue arrows are, what is 6 minus 8? And on the inside, 2 times 6 is 12, and 16 minus 12 is 4, and the square root of 4 is 2. Was that okay? Did I go too fast? Just changed x into a number and then worked it out. Does negative 2 equal 2? No, I don't mean to insult you when I ask you that question. I promise that I don't. But they are not the same number. Therefore, the equal sign is bunk. Therefore, the statement is bunk. Therefore, 6 is bunk. Cross it out. That's an extraneous solution. Let's go check 8. See what happens. Again, go to the top and go to where the blue arrows are, and let's change them both into 8s. What is 8 minus 8? You're fine. 0. And then inside the root sign, right here, I'm going to underline it for you. What is 2 times 8? What is 16 minus 16? What's the square root of 0? 0 equals 0. 8 can have a box. So on a delta math problem, when it comes to the answer, you would type in 8 for your answer, not both of them, because again, one of them failed us. Did that feel a little better, Colby, this time? Yeah, if you ever get nothing working, you can do, you can actually just leave the box blank and hit submit, and it counts that as no solution. Yep. Shall we go again? Round 3? Brandon, you know, I'm a huge fan. This year, once and for all, I am officially on Team Winslow. I'm a fan, but I don't like it when you say stuff like that. That gives people terrible ideas. Yeah, let's stop finding workarounds. Sound like a deal? All right. All right, guys, let's do this. Square the left, square the right. What do we get on the left? What do we get on the right?
For x squared minus 4. Plus 4.
Estos números aquí y aquí, 100%, siempre positivo, los dos. They have to be positive because you're always squaring things to get them, guys. So where those red arrows are pointing, don't ever say negative. Okay, it's always starts with a positive, ends with a plus. Now the one in the middle will always mimic the sign of his predecessor. So this minus will always be the same as right here, right? All right, which side are we moving all of our stuff to, left or right?
Right.
A la derecha, x cuadrado más x menos 2 igual a 0. I hope you're comfortable with me not showing every little step. I mean, I added 5x to both sides. I subtracted 6 from both sides. You can show that if you'd like. It's up to you. All right, let's factor. I got an x. I got an x. I got my equals 0. Tell me about my signs. Got to be plus and minus. Not even up for debate. And there's not a lot of ways to multiply to make 2. You just got to be smart about where you put the 2 and where you put the 1. Who should I put with the plus?
1.
the 2. And I want to make sure that I put them in those places to make sure that when I add my connectors that I get +1 in the middle, not -1. So what are my candidates? And correct. So let's go test our candidates. You can see this is going significantly quicker than our first example. Shouldn't take too long. If I take -2 and I put it where the little blue arrows are, here and here. And Eli asked a question somewhat similar to this, not quite the same question, but similar to this. What are you going to get for this green bubble cloud that I'm drawing? Should be a part of this to make sure you know what you're doing. If you put -2 inside that little green bubble cloud where the X is, what do you get? You don't get -4. Would you believe me if I told you you get 16? Replace X with -2, and do you see how it's a -5 times a -2, which is really +10? 6 plus 10 is 16. What's the square root of 16? So I get 4 equals, and over here where the other blue arrow is, what's -2 minus 2? 4 does not equal -4. X equals -2 can get across. Let's check 1. Again, I know I vandalized it quite a bit, but where those little blue arrows are, replace the X's that you see with 1s. Inside the root, what is 5 times 1 is 5. What's 6 minus 5? And the square root of 1 is 1. Okay. And then on the right side, what's 1 minus 2? -1. 1 does not equal -1. It gets across. This one, if you were taking a test, like on paper, which you will eventually, you would actually physically write no solution. But if it's on Delta, like I said, you can just leave the box blank and submit it. Good. Really?
Yeah.
I'm never sarcastic. You guys want to do one more, or are you good? Brandon's. I don't know what are you doing over there? Are you coloring or something?
No.
Oh. Okay. Let's do one more. Okay. This will be my last example, unless you want me to conjure up some more. But otherwise, I'd like you to get started on your assignment after this. So here we go. If you're falling asleep, I have a couple thoughts on that. Number one, I totally understand. But my second thought is, don't write this down. You'll learn more, time goes faster, and you'll stay awake if you write this down. So here we go. I am. Deep thoughts with Mr. Ahern. All right, let's square both sides. What do we get on the left? The moment of truth. You did a great job with the x squared plus 16. Yeah. It's okay. Practice makes perfect, okay? That was a really, again, a very solid effort on the square, multiply, double. Don't make any mistakes in step one. Otherwise, obviously, the rest of the problem kind of can't really work. So which side are we coming to, left or right? Well, I would want to go to the right. Yeah, basically, if you've forgotten, wherever x squared, remember, x squared is like the grandpappy term. He's like the, hey, oh, you guys come to my house. Wherever x squared is going to be positive, we leave him there and everyone comes to his house. So x squared stays put. How many x's will we have? I agree. We'll have 4. So we have plus 4x because I subtracted 4x. And I got to subtract 28. What's 16 minus 28? Good basics. And there it is. If everything has gone well to this point, there's your little factorable quadratic. Another thing, too, with this particular assignment, if this quadratic is not factorable, you've done something wrong. This whole assignment is built on nice solutions. And so if you can't factor it, either you suck at factoring or something else has gone wrong before that. So I'm going to build my shells. Definitely, Bryce, a plus and a minus. And now we definitely want to consider the 6 and the 2. Yeah, we want the 6 in here where the positive is and the wimpier 2 over here with the minus so that it balances correctly. I think so. Yeah, there shouldn't be anything super hard. Maybe. I don't know. If it happens, just let me know. So anyways, what are my candidates? And then you go back up to the beginning and you check those candidates. So right up here, again, I'll use my little blue arrows again. All you got to do is change those X's into your candidates. So if you put in -6 in the first X, what's 4 times -6? Plus 28. Square root of 4. Square root of 4 is 2. Now put -6 over here on the right blue arrow. What's -6 plus 4? 2 does not equal -2, so that answer can get across. Let's check 2. Again, up where the blue arrows are, what's 4 times 2? 8 plus 28. Square root of 36. On the right side, 2 plus 4. 6 equals 6. 2 can have a box. This is what you're doing today and tomorrow, basically. You got it?
Yeah.
All right. It's on the delta. Huh? Not right this second, no.